All right, welcome back to Statistical Analysis in Psychology. This is week 16, class number 1. And today we're going to finish up two things. We're going to finish up chapter 10, our look at the introduction to the analysis of variance, where we're now going to see how to actually do an analysis of variance using SPSS. And more importantly, we're going to finish up our look at statistics. So this is it. After today, we will have covered everything that we wanted to cover in this introduction to statistical analysis course. So welcome to Day 9 of our face-to-face shutdown. Welcome to your final step towards completing your introduction to statistics. All right, so on to ANOVAs, on to finishing this semester in statistics. So we introduced this question last time about looking at, in animal psychology, why do birds migrate? So some birds migrate phenomenal distances and take a heavy toll on their body, and it's risky and it's dangerous and it's very physically taxing, and other birds don't. So why do some birds migrate and other birds don't? Well, some researchers postulated that it might be due to the intelligence of these birds. So birds with different brain sizes, they hypothesized, would have different intelligence. And they were wondering if it might be the fact that birds that are intelligent enough to survive in the winter, they're the ones that don't migrate. So a blue jay is intelligent enough and has the cognitive skills to survive in the winter, whereas a bird like an Arctic tern might not have the skills to survive in a climate during the winter. So it needs to move from climate to climate and migrate in order to survive. So we're going to take a look at how we would analyze that experiment, because in that experiment, they didn't just look at two types of birds, non-migrating versus migrating. They looked at three types of birds, non-migrating, short distance, and long distance migrating. And that three types of birds necessitated the use of an ANOVA. So that's what we're going to be focusing on today. We're going to take a look at how to do ANOVAs in SPSS. And for those of you that might have tried to work ahead a little bit and do ANOVAs by hand, and also for all of you that read through the chapter to get prepared for this class, you know that ANOVAs are difficult to do by hand, are very challenging. So thank goodness we have the tools that we have in SPSS. I'm going to mention homework assignment number 14, mention the chapter 10 post-test, because we're in that final section of the semester where we're preparing for the final exam. So the due dates are going to be a little bit weirder than usual. So I'll just point out some of that. And then I'll just mention the extra practice that you have available. And that will be it. All right, so independent means ANOVA, let's set it up. So one possible explanation for why some birds migrate and others maintain year-round residency in a single location is intelligence. Specifically, birds with small brains relative to their body size are simply not smart enough to find food during the winter and must migrate to warmer climates where food is easily available. And that was Saul and his colleagues in 2005. Birds with bigger brains, on the other hand, are more creative and can find food even when the weather turns harsh. Just so you know, I used to work in a research lab where they did bird memory research, and the ability of some birds to remember locations of food is phenomenal. We are talking about hundreds of locations memorized and able to be recalled from memory. So the intelligence of some birds is it's astounding. Anyways, back to the matter at hand. Following our hypothetical data similar to the actual research results, the numbers represent relative brain size for the individual birds in each sample. And we are going to use an ANOVA with an alpha of 0.05 to determine whether there are any significant mean differences among the three groups of birds. So let's take a look at that hypothetical data right now. So we have three different populations, and we took samples from each of those populations. So population number one were non-migrating birds. So we took a sample of non-migrating birds and measured their relative brain size. And the way that that measurement works is that basically the higher the score, the bigger your brain is compared to your body. So we have one population, non-migrating birds. We take a sample from that population. Population number two, short distance migrating birds. We take a sample from that population. If that was all we did, those two populations, then we would do a t-test. However, we're interested in a third population as well, long distance migrating birds, because we're wondering that, well, maybe intelligence increases the shorter you migrate, right? Maybe the long distance migrating birds have the smallest brains. Short distance, the next smallest, with long distance migrating birds have the smallest brain, then short distance, then non-migrating birds have the biggest brains. So we have 3 populations. Once we have samples from 3 populations, we need to do an ANOVA. We lose the ability to do a t-test, as we mentioned last class, and now we need to do an ANOVA. So let's take a look at some of these scores. So we have 6 birds in our sample from the non-migrating group, and there are their relative brain sizes, mean relative brain size of 15. 6 birds from the short distance migrating group, there are their relative brain sizes, mean relative brain size for that sample of 9. And then finally, we have 6 birds from the long distance migrating group, and there are their relative brain scores, and they have a mean relative brain score of 6. So we need to do a hypothesis test now that we have this data. Thank goodness, though, this is a hypothesis test. And as I mentioned before, your hypothesis testing procedure is going to be the 5 steps. Sure, we're going to make some tweaks when we change from different situations, but it's always going to be those 5 steps, and that still stays the same for the ANOVA. It's exactly the same, just a couple of tweaks along the line. First tweak actually happens straight off the bat, and that is restating the question as a research hypothesis and a null hypothesis about the population. So we want to know, do birds that migrate shorter distances have bigger brains? That's the question that they're asking. So our first step here is to come up with the null hypothesis. Now, one thing about the null hypothesis for this independent means ANOVA, so again, just to kind of backtrack real quick a little bit, we're only focusing on independent means ANOVAs here, and that means that the birds in sample number 1 are different from the birds in sample number 2, are different from the birds in sample number 3. And we're starting with that ANOVA because that's the simplest one. We're going to finish with that ANOVA because it's the end of the semester. But anyways, let's concentrate on the task at hand. Null hypothesis. The null hypothesis is that the bird sizes are not different for birds that migrate different distances. That is, brain size does not affect migration. So this is easily written, and it's an extension of the null hypothesis that we've been working with, as the mean brain size of non-migrating birds equals the mean brain size of short distance migrating birds equals the mean brain size of long distance migrating birds. That's the null hypothesis, easily written out. It's just that the means for each population equals the means for every other population. So that's a null hypothesis. Research hypothesis has to be the complete opposite. It has to take into account every other possible outcome. And if the null hypothesis is that brain sizes are not different for birds that migrate different distances, the research hypothesis becomes that they are different. And one way of saying that is that at least one brain size is different for birds that migrate different distances. It could be just one of them, it could be all 3 of them, but at least one of them is different. And that's your research hypothesis. Now, with 3 conditions, it would be possible to write out every single combination of at least one brain size is different for the different birds. It would get complicated, but it would be possible. But we're going to get into the habit of not doing that because it gets complicated very quickly. So we're just going to write this out as the English sentence. At least one brain size is different for birds that migrate different distances. So we have our research hypothesis here. We have our null hypothesis. On to step 2. All right, step 2. Determine the characteristics of the comparison distribution. If we were doing this by hand, this would require a bunch of calculations. Thankfully, SPSS is going to do this for us. Step number 3, set a cutoff probability. SPSS is not going to do this for us. I almost jumped the gun there, because the cutoff probability is your alpha. So once again, your cutoff probability, your probability line in the sand, that's your alpha level, and that in this case is 0.05. There is an F statistic table where you can look up cutoff scores for your homework. So your homework will ask you for cutoff scores. That is in the F statistic table. That works much like the tables that we've already used. So we're not going to explicitly cover that in today's class because number 1, this is what you need for the exam. Number 2, you've done it before. And number 3, we're doing this the way that we would in the real world, which is not to consult the tables. So we're going to go straight into using a cutoff probability, Your cutoff probability is your alpha level. In this case, alpha level is 0.05, and that was given to you in the question. Step number 4, determine your sample's probability on the comparison distribution. That is your probability value, that is your p-value, and SPSS is going to do this for you. So we are now going to dive into steps 2 through 4. So if you haven't already, fire up SPSS, go to IU Anywhere, log in with your user ID, fire up that SPSS, and also if you haven't already, go to Canvas and open up the Excel sheet that has the data that we need. So if you need to, pause the video at this moment so you can get those open. I'll just mention that, as always, the screen grabs are in the PowerPoint files so that you can have those visually for you to follow along with. And also, you have this video as well. So without further ado, let's start setting up our hypothesis test. And again, if you need to, pause the video, get set, get everything ready, and let's do this thing. All right, so the first thing that I'll point out is that this is the data that you're looking for. So here are the scores for the bird brains. And just like with a t-test, you need the raw scores. You need the raw scores if you're going to be doing your ANOVA. So if you're going to be using SPSS, you need to know what the raw score was, the brain size, for bird number 1 in the non-migrating condition. You need to know what was the brain size for bird number 5 in the short distance migrating condition. You need all of those scores. All right, so we have our scores here. So the next thing that we're going to do is we are going to make sure that we got SPSS open, like I do right here. We'll close that welcome screen and we'll go into the data editor here. Now, this is an independent means ANOVA. And one thing that we're going to do is we're going to remember that every single row in SPSS is reserved for one and only one subject. In this case, it's reserved for one and only one bird. So this independent means ANOVA is going to work a lot like the independent means t-test that we used to do in terms of its formatting. So what we're going to do is we are going to take this data right here. We're going to copy the raw scores for the non-migrating birds, and we are going to put that into row 1, column 1, and we are going to call that brain. So var 00001, SPSS's automatic naming convention, horrible for our human brains. So we're going to go down here to variable view, we're going to click on that, and we're going to call that something that works for our human minds, which is brain. So that's the brain size. And then we're going to remember that all the information for any single subject has to be in the same row, right? So we're going to remember how we used to set up a t-test, that was an independent means t-test, where we would have a column of raw scores, and then we would have a column of group names. So we're going to do that here, and we're going to call this one non-migrate. And we are going to copy and paste that all the way down. And then we are going to call var 00002. We're going to call this group, we're going to call this group NM for group name. And why I'm calling it group name is going to come up in just a moment. But we're going to call it group NM. Notice that that is 8 characters or less. So we're safe with SPSS, and we have non-migrate here in group NM. All right, so next thing we need to do is we need to enter in the data for the short distance migrating birds. So following what we learned when we were doing the independent means t-test, for this independent means ANOVA, this new sample with these new subjects gets a new set of rows. So they get their very own rows, rows 7 through 12, and these ones are going to be the short distance. So we're just going to call them short, and we're going to copy that, and we're going to paste it all the way down. And we have those set up, and you can probably guess how we're going to finish this all off. We're going to go back here. We're going to take the long distance migrating bird brain scores, We're going to paste those into their own rows. So these birds get rows 13 to 18 because, again, every single bird gets a single row. And we are going to call these ones long, just to jog our memory that these are the long distance migrating birds. Okay, so that was the group names. What we're going to do now is we're going to make one more column, and we're going to call this one, we're just going to number the groups. So we have a column filled with the group names, much like we would do with a independent means t-test. But now what we're going to do is we're going to number these groups as well. So we're going to call the non-migrating birds group number 1. And let's go to variable view right now, and we're just going to update this to group. All right, so we got group over here, and we're going to number the non-migrating groups, and we're going to say, you know what, you're group 1. We're just going to call you group 1. And then the short distance migrating birds, they're group 2. And then the long distance migrating birds, they're group 3. So we're just going to set this up, and the payoff's going to come right about now when we start to do the ANOVA. But we have this set up. We have one column with all the brain score sizes. We call that one brain. We have one column with the group names. We call that one group nim. And then we have one column of group numbers, and we two of which are identifying the groups. Well, the reason it comes when we go to analyze and we go to compare means and we go to one-way ANOVA. So very nicely, this ANOVA is still in the same menu that we've been finding all of our hypothesis tests. So you remember the greatest hits like one sample t-test and independent samples t-test and pair samples t-test. Well, they're still there, but now we're going to be doing that one-way ANOVA. So once again, we go to analyze, we go to compare means, and this time we're going to one-way ANOVA. So we click on that, and then we're going to start to put the variables into the different windows in terms of where they want to go. But what I want you to notice right now is notice here in our list of variables, one of them is missing, right? One of our variables is missing. We had 3 variables. Now we only have 2. And notice it's the one that had the group names. So unlike an independent means t-test, an independent means ANOVA, for some reason, and don't ask me why, but for some reason, it doesn't allow you to use names for your groups. So that's why we did it this way. You have to number your groups. So you can just number them group 1, 2, and 3. If you have 4 groups, group 1, 2, 3, and 4. But you need to number the groups. And I would highly recommend, because of our human minds, label those somewhere. Take out a piece of paper, right next to each of them, number 1 equals non-migrating, number 2 equals short distance migrating, number 3 equals long distance migrating. Your human mind will thank you, and you will not hate yourself when you forget what those are, or when you need to do the mental gymnastics. So do yourself a favor, write those down on a separate piece of paper. There is a way to do that in SPSS, but I don't want to overload you. If you're feeling frisky and you want to give it a shot, there's a ton of YouTube videos on how to do that. But for right now, it's just good enough. Jot it down somewhere, give your human mind a rest, and make sure that you know which numbers go with which groups. So now that we have that taken care of, we have to decide where do our different groups go? Sorry, where do our different variables go? So what we're going to do is we're going to take brain, and brain where we have our raw scores, the variable where we have our raw scores, where we have our brain sizes, that goes into your dependent list. So we're going to click on this, and we're going to use this arrow to move it into the dependent list. If you make a mistake, like you put group into the dependent list, well then just highlight that variable and you can pop it back out, right? So we're going to put brain into the dependent list. Dependent list is where you have all of your raw scores, where you have your raw data, your raw scores for each subject. And then we got factor down here, and not surprisingly, this is going to be where we put group. So factor is that factor that we were talking about before, is the cause that we were looking at before. And we are seeing if the different migrating distances are caused by the different brain sizes. So that's our factor. That's how we're differentiating the birds. That's the one that has the different levels. So it has the 3 levels. So that's our factor. And then the last thing we're going to do, and we're going to do this, and the payoff again is going to come in just a little bit. Oh, I'm sorry. One of the things we're going to do is once we have it set up like this, we're going to go to options here. And for options, you want to click on this descriptive options tab here, and that is going to be, we're going to use that table to basically check our work. That's like that descriptive table that we've been using before. Now, all of these other things here, these other options, you're going to learn what those are in your next stats class, right? So after your intro, when you go to grad school and you take stats there, you're going to learn what those other buttons are for. The one thing I'll mention right now is that whenever you're using SPSS and you get into something as high as an ANOVA, you never want to click all the buttons because you will end up with 80 pages of output and you will just have a tough time trying to figure out what it is that you want to look at. So make sure that you always click what you need to, but don't click any extras that you're not going to be really using. So we hit continue. Once again, that is found in this options. So we hit continue and we're going to hit OK. And we have our ANOVA run. All right, so that is the ANOVA. And what we're going to do right now is we're going to take a look at these two tables and we are going to discover how do we read this ANOVA to complete the hypothesis test. So here's the output as well. We are going to get to those other tables in just a little bit, but this is the output. It's formatted slightly differently because it was on a previous version, but everything is still in the same place. So let's get going on this analysis. All right, so let's go back to step number 2. We need to determine the characteristics of our comparison distribution. What are the characteristics of that F distribution for our distribution of sample means? All right, so what are the characteristics of that F distribution? Well, we're going to hone in on these first top 2 tables, and we're going to get to step number 2 in just a moment. The first thing we want to do is we want to take a look at that descriptive table. So that top table labeled descriptives, that's the one that we asked for in the options. And we asked for it because it's going to be the one that helps us check our work. So the first and foremost, the biggest thing you want to do is you want to go to that column labeled N, and you want to make sure that you have the right number of birds in each group. Because when you are numbering that, and you're going 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 3, 3, 3, 3, 3, it is so easy for your finger to slip and you go one subject too many or one subject too few. So that's the first and foremost one that you want to check. So we take a look at that, and it is saying, SPSS is telling us, I have 6 scores in group number 1. And we look down at our little paper where we jotted our information and we say, you know what? There were 6 subjects, there were 6 birds in the non-migrating birds. That's great. SPSS is also telling us we got 6 subjects in group number 2. You check your little jotted down list and you say, yeah, that's great. There were 6 birds in the short distance migrating group. And then finally, SPSS tells us, hey, I got 6 subjects in group number 3. We check our notes and say, yep, that's what you're supposed to have. There were 6 subjects in the long distance migrating group. So that's double check number 1. Double check number 2, it has the means that SPSS calculated for each group. And we double check that against what we have in Excel. All the means match. That gives us confidence that we entered in the data correctly. That gives us confidence that we didn't have a slip of the finger that is going to make everything else come out incorrect. Gives us the confidence that we have to proceed with our analysis. All right, so now that we have that confidence, we're ready to take a look at the bottom table, which is the ANOVA table. So remember last time we talked about between treatments and within treatments variance. Here it's labeled between groups and within groups, and then total is the one at the bottom, total variance. So don't worry about the fact that it's between groups rather than between variance, or within groups rather than within variance. The important stuff is whether it's between or whether it's within. Because between groups, between variance, same thing. Between treatments, it's the same thing. It's the between part that's the important label. Some people say groups, some people say treatments. They're both right. Look for the between. So when we're looking for our comparison distribution, what we need to know is we need to know the degrees of freedom for between treatments and we need to know the degrees of freedom for within treatments, and we have that in the table right there. So we have 2 degrees of freedom for the between treatments variance, and we have 15 degrees of freedom for the within treatments variance, and that determines our comparison distribution. That determines that F distribution that we saw yesterday, those 2 degrees of freedom. So that is step number 2. We have 2 between treatments degrees of freedom, and we have 15 within treatments degrees of freedom. Step number 3 is your alpha level. Your cutoff probability. That's your alpha level. That's your line in the sand. Step number 4 we're going to get to in just a moment, but this is a good time to mention that step number 5 is still the same as it was this entire time. So just because we're doing an ANOVA doesn't mean at all that step number 5 changes. So it's still going to be that if the p-value that we get is less than our alpha level, we're going to accept the research hypothesis and we're going to reject the null hypothesis. On the other hand, if the p-value is greater than our alpha, the probability of getting samples this weird is greater than our probability line in the sand. We're going to accept the null hypothesis and we're going to reject the research hypothesis. So now we need to find that F statistic for step number 4, and we need to find our probability for our sample differences. That's also step number 4, and then we need to compare them to our alpha for step number 5. So we didn't mention the F statistic. You're going to need that in your homework. Thank goodness SPSS calculates the F statistic for your hypothesis test, and you can find that right there. So in that ANOVA table, under the column labeled F, that's your F statistic. That would be your ANOVA's F statistic that you would calculate and you would report. However, that is tied directly to a probability. That is tied directly to a p-value, and the p-value is what we're using here, and that p-value is right there. So that significance is your p-value. This one does not say two-tailed, because in reality, all ANOVAs, you can think of them as two-tailed. You'll see that the null hypothesis that we used is just an extension of the two-tailed t-test hypothesis. So all of the ANOVAs are two-tailed, so you're not going to see significance in brackets two-tailed. So make sure that you know which one to go to. Make sure that you know to go to the ANOVA table, and that one labeled significance is your p-value. And in this case, you can see that the p-value is 0.000. There's a 1 somewhere down the line. It just can't be displayed here. But for our purposes, a p-value of 0.00 will help us make the right decision. So that's where your p-value is. So that is your step 4. F statistic of 19.286, p-value of 0.00. Now we're ready to go to step 5. If your p-value is less than your alpha level, accept the research hypothesis and reject the null hypothesis. Turns out our p-value is less than our alpha value. 0.000 is less than 0.05. So that's what we're going to do. We're going to accept the research hypothesis. We're going to reject the null hypothesis. If the other situation occurred, if the p-value is greater than alpha, then we would do the opposite. We would accept the null hypothesis and reject the research hypothesis. As it is, our p-value is less than our alpha, so we reject the research hypothesis and we accept the we reject the null hypothesis and we accept the research hypothesis. So we can now conclude that at least one brain size is different for birds that migrate different distances. We found a significant result. We accepted the research hypothesis, and we know now that at least one of these populations has a different brain size than at least one of the other populations. So let's pause there for a moment and try to identify, is there a problem with our conclusion? Is there something missing from our conclusion? Can you figure it out? What is it that we still don't know that we would need to know as psychologists? All right, did you figure it out? If not, maybe pause, come back, give it a shot. All right, at this point, let's see if you got it correctly. So the ANOVA returned a significant result. We rejected the null hypothesis. We accepted the research hypothesis. We now know that at least one brain size is different for birds that migrate different distances. The missing information, though, is which brain sizes. right? Which one is it? Is it that non-migrating birds have different brain sizes than short distance migrating birds? And or is it that non-migrating birds have different brain sizes than long distance migrating birds? And or is it that short distance birds have greater brain sizes or different brain sizes than long distance migrating birds? Which one is it? Is it just one of them? Is it two of them? Is it all three? If it's one of them, which one? If it's two of them, which two? If it's all three, well, we know which all three it would be, but is it all three? So we're missing information. We don't know, and this is an incomplete test. We got a significant result. That's great. What does it mean? It's incomplete. So what we're going to do now is we're going to add on that last little part that we need, and that is the post hoc tests. So the post hoc tests is what takes your ANOVA to that final level where if you find a difference, you can hone in directly on where that difference is. Now to do the post hoc test, we're going to go back to SPSS here, and we are going to clear out, we're going to close our output here. We're not going to save it. And we are going to go back to analyze. We're going to go back to compare means. We're going to go back to Way ANOVA. So we're doing exactly what we did before. And you can see here that there's this nice little button that we didn't press the first time that says post hoc. So we're going to click on that, and it brings up all of these options for your post hoc test. It brings up all of these possible post hoc multiple comparisons. So the first thing that you want to do is you do not want to click on everything. You click on everything, you're going to have a 200-page output, so definitely don't do that. The next thing you want to do is you want to choose which post hoc test you're going to use. Now, for the purposes of this course, you will be told which one to use. So in your homework, keep an eye out for them to say, use the Bonferroni post hoc test. Use Tukey's honestly significant difference post hoc test. Keep your eye out for which test they ask you to use. In the exam as well, I will tell you which test you're going to use. So personally, for myself, I prefer the SIDAC post hoc analysis. I just found a new one actually that they developed called the Benjamini-Hochberg post hoc analysis, which I just love because Benjamini is just so much fun to say. But SIDAC is a very popular one. Bonferroni, the San Francisco treat, is also a very popular one. And Tukey's honestly significant difference is also a very popular one. And it's just labeled Tukey here. Those are the ones that are probably the top three. We're going to be using Tukey for this example. But again, make sure that you read, when you read the question, identify which post hoc analysis they want you to do. For this purpose, we're going to do Tukey. The last thing you want to do before we hit continue here is this significance level down here. You're going to want to set that to your alpha level. And what that will do is it will give SPSS, it'll ask SPSS to do a double check for you when you're looking at the table that we're about to generate. So it's just another nice little double check just to make sure that we're analyzing our post hoc analyses correctly. So we've set up our post hoc analysis. So we've chosen Tukey. We've set our significance level to the alpha level given in the question. We now hit continue. We now hit OK. And lo and behold, we have this new table down here. We got one down here as well, but we're not going to look at that one. We got this new table down here that is the multiple comparison table, and that is our post hoc analysis. So now that we have that one, let's analyze it. Let's see how we can answer which population of bird brains is different from which other population. So we're going to zoom in on that multiple comparisons. First thing to notice is that in the table labeled multiple comparisons, it says under brain, it says Tukey's HSD, honestly significant difference. So it reminds you which post hoc analysis you chose. So that's a good thing just to kind of double check, just make sure that you've done it correctly. You didn't click on the wrong one, just to make sure that you actually did do the correct test. All right, so now we're going to see how to read this table. The way that it goes is in that first column, it tells you which two populations it's comparing, right? It tells you whether it's comparing population 1 to population number 2, population 2 to population number 3. It tells you which one it's comparing to which other one. In the second column there, it calculates the mean difference between the samples from those populations. And then importantly for us, most importantly for us, that fourth column there gives you the p-value for that comparison. So you can think of this almost as a series of t-tests that have been done after we found a difference. So we don't worry about, the experiment-wise error rate. This is found after we found the difference. And also, Tukey, SIDAC, and everybody else that developed these post hoc analyses, they developed them specifically to control for the inflation of that error, that experiment-wise error rate. So these are controlled tests. They kind of work like a t-test, but they're subtly different. But for our purposes, we can treat them as if they're a t-test and interpret their outcomes in that manner. So let's take a look at them. So they're pairwise comparisons. So the first thing we want to do is we want to compare the non-migrating birds to the short distance migrating birds. That's the first question we have. Are the brains of the non-migrating birds different from the brains of the short distance migrating birds? So on this table, in that first column, we need to find the non-migrating birds group, and we need to find a row that has a non-migrating bird group and has the short distance migrating bird group. So again, we go back to our little notes that we made, and we say to ourselves, all right, non-migrating, all right, there's sample number 1. Short distance migrating, all right, there's sample number 2. So we need to find a line where sample number 1 is compared to sample number 2, and there's the line right there. So sample number 1 compared to sample number 2. Before we get into that, notice that this table is completely redundant, because on that first line, we have sample number 1 compared to sample number 2. And then on the third line, we got sample number 2 compared to sample number 1. It's there whichever way you want to do it, whichever way makes the most sense for you, but we're going to use row number 1 there. So we're comparing sample number 1, non-migrating birds, to sample number 2, short distance migrating birds. Second column there says that the mean difference is 6. So there's a difference of 6 between the brain sizes. But most importantly for us is that significance value, that fourth column. And that significance value is 0.003. And we use that much like we do step 5 for a t-test. We take a look at that significant value. We say, is it less than alpha? If it is, we reject the null hypothesis and we say there's a difference between these two populations. If it's greater than alpha, we accept the null hypothesis and we say there's no difference between these two. As it is, 0.003 is lower than our alpha level of 0.05. And you will also notice that in column number 2, in that mean difference, I minus j column, the 6 there has an asterisk. And that means that SPSS has identified that comparison as being significant at the level we asked it to identify when we were setting up the post hoc analysis. So if you take a look at the asterisks on this table, it says the mean difference is significant at the 0.05 level. That is, the mean difference is significant at the level we asked SPSS to analyze it. So that asterisk is your double check. So go to the significance table, make your determination, and then double check with that mean difference I minus j column just to see if there is a significant difference, you should see the asterisk. If there's no significant difference, you shouldn't see the asterisk. Other way of saying that, if you are rejecting the null hypothesis, you should see an asterisk. If you're not rejecting the null hypothesis, no asterisk. As it is for this comparison, non-migrating to short distance migrating birds, our significant level, our p-value is less than our alpha. We see the asterisk, that's our double check. We are rejecting the null hypothesis. And the post hoc analysis reveals that non-migrating birds have different brain sizes than short distance migrating birds. So that's one of the differences. We found our first difference. We knew there must be at least one difference between the populations. We found at least one. The brain sizes for non-migrating birds larger than the brain sizes for short distance migrating birds. Now we're going to take a look at non-migrating birds versus long distance migrating birds. Is there a difference there? So we go back to our table and we consult our little notes, and we need to find non-migrating birds group 1 compared to long distance migrating birds group 3. Now this is where I get a little agitated at this table, because one of the places to find that is in row number 2. And I don't know what SPSS's thought process was on this. I don't know if they wanted to save virtual ink, but they don't duplicate that group 1 in that second row. So you are to understand that they meant that group 1 to continue. So that line is actually group 1 versus group 3. You can also see that there's the redundant group 3 versus group 1. You can use that line as well. The results are going to be the same. Important for us, though, we found the correct line. Go to that significance, fourth column. See that the p-value for this comparison is 0.000. That is less than 0.05. So we're going to reject the null hypothesis, and we're going to conclude that there actually is a difference between these two populations. Take a look at the second column there, mean difference, I minus j, and notice that that 9 has an asterisk on it, meaning that SPSS also identified this as significantly different. They've also rejected the null hypothesis for this comparison. So we can conclude after that double check that non-distance migrating birds do have different brain sizes than long-distance migrating birds. The brain sizes of non-migrating birds are bigger than long-distance migrating birds. All right, so we got one last comparison to do. What about the short-distance birds versus the long-distance birds? So we need to go back to the table, and we go back to our little notes, and we say, all right, what was short distance? Short distance was group number 2. Long distance migrating birds, group number 3. All right, so we need to find 2 versus 3 on this table. 2 versus 3 is right there. Remember that the 2 carries down. And this time we go to that significance column, column number 4, and we see that the p-value for this comparison is 0.138. 0.138 is greater than 0.05. So according to our decision tree, we accept the null hypothesis. We accept that there's no difference between these two groups. And when we go to that second column and look at what SPSS has analyzed, notice that the second column, that mean difference of 3, has no asterisk, which means that SPSS also did not identify this as a significant difference. It also accepted the null hypothesis. So in this case, we accept the null hypothesis, and we conclude that short distance birds have no different brain sizes than long distance migrating birds. And now finally we have the full picture. If you're smart enough as a bird to not migrate, you won't migrate. If you're a smart bird, you don't migrate. If you're not smart enough, you will migrate. And there's no difference between birds that migrate a short distance versus birds that migrate a large distance. The key difference in intelligence is between birds that migrate and birds that don't migrate. So whether or not you migrate a short distance or a long distance, you're still migrating. Their cognitive abilities are not different. What is different are the birds that do not migrate, are non-migrating birds, and that came out in the post hoc analysis. All right, that was it. That is our final hypothesis test. So before we go, just a couple of reminders. Homework assignment number 14, that is available in the MyLab. That is going to be due April 29th by midnight. And then you also have chapter 10 post-test, and because of the upcoming exam, that is going to be due May 4th at midnight. And then also we had a pre-test for chapter 10. And if you didn't get 100% on that pre-test, feel free to earn those MyStatLab study plan mastery points. And you have until the 6th of May by midnight to do that. That is the day before the exam. So once again, just to make sure that you're focusing on getting prepped for the exam, we're going to set the due date for that just right prior to the exam. And just want to let you know that we would typically do this in class, but this is now take-home practice. It's another practice problem covering Chapter 10, Introduction to Analysis of Variance. The description there is about keyboard designs. So in your PowerPoint lecture notes, you have the description, you have the output that you should find, so you can compare your output to that, and then you also have the conclusions that you should have. So try to do those without looking at the answers right here. If you can, look at the answers if you can't get them right, or to check your answers. And then finally, if this isn't working for you, if you're struggling with ANOVAs, please come to the review session next class. This again is a special review section. This is like extra stuff that is not regularly scheduled, but I'm doing it just to make sure that we can have that understanding of analysis of variance or confidence levels if you need it. Come to the office hours as well. Let's make sure that we end this semester strongly. Let's make sure that we get ANOVAs down because they are massively useful. And let's make sure that we're doing the best that we can do. So that is it for today's class. Thank you for joining me on this week 16, class number 1. That is actually it for what I'm going to cover in the semester. So super thank you for joining me during this semester. Thanks for hanging in there during this little wild and crazy quarantine session part. And as always, thanks for coming by. Keep yourself safe. And I will see you if you come to review session. Other than that, thanks for playing along. And I hope to see you again in another one of my classes. Take care.